Okay. All right, so for problems 1 through 4, we'll just use the properties of logarithms to expand each logarithmic expression as much as possible, and where possible, evaluate logarithmic expressions without using a calculator. So in problem number 1, here we've got log to the base 8 of 13 times 7. Now, in section 4.3, we did 3 different rules for properties of logarithms. One of them was the product rule, the other one was the quotient rule, and the third one was the power rule. So what rule do I need to use here to expand this logarithmic expression? The product rule, because notice I have a log of the product. I need to write that as the sum of their individual logarithms. So log to the base 8 of 13 times 7 would be log to the base 8 of 13 plus log to the base 8 of 7. Okay. And that would be as far as I can go with that problem, because I can't find out 8 to what power would give me 13. Nor can I find out 8 to what power would give me 7. Or just finding a whole number exponent to be exact. All right, questions about problem number 1.
So when you don't multiply 13 times 7?
No. Because it's a log of the, even though it's a log of the product rule says that you must expand that as the sum of their individual logarithms. Okay? That's back in section 4.3. Any other questions? Okay, problem number 2. You've got the natural logarithm of e to the 4th divided by 8. Natural logarithm of e to the 4th divided by 8. In this case, what rule do I need to use here? Quotient rule. Because notice I have the log of the quotient, or the natural logarithm of the quotient. I can write that as a difference of the individual natural logarithms. So ln of e to the 4th divided by 8 will be expanded as ln of the numerator, e to the 4th, minus ln of the denominator, which is 8. But I can simplify that a little bit further by using one of the inverse properties for natural logarithms and the base e. If you recall, if you have the natural logarithm of e to whatever your exponent is, it's going to be that exponent. So what would ln of e to the 4th be? 4. Keep in mind, e and ln are inverses of each other. So I have 4 minus ln of 8. And that will be simplified as far as possible. Are there any questions about problem number 2? Number 3, here I got the log of n to the negative 6 power. Log of n to the negative 6 power. What rule can be used here? It's either the product or the quotient of the power rule. Power rule, because notice that the n raised to the negative 6 power. That means I can expand that by pulling that exponent in front of the logarithm. So that negative 6 will go in front of the log of n. And that's all there is to it. So here log of n to the negative 6 will be expanded using the power rule as negative 6 times the log of n. Okay. Questions on problem 3. Number 4, we got log to the base 8 of 64 divided by the square root of x plus 1. Log to the base 8 of 64 divided by the square root of x plus 1. Okay, now we need to expand this as much as possible. So to begin with, what rule do I need to use here? Quotient rule. Because notice I have a numerator and a denominator. That means I have the log to the base 8 of the quotient. I can write that as the difference of the individual logarithms. So here I'm going to have log to the base 8 of the numerator, which is 64, minus log to the base 8 of the denominator, the square root of x plus 1. Now what I'm going to do here is rewrite the square root of x plus 1 in its equivalent exponential form. So let me bring down log to the base 8 of 64 minus log to the base 8 of. The square root of x plus 1 in its equivalent exponential form will be what? To the 1/2. Because it's a square root, that means it's got to be to the 1/2 power. All right, so now let's do some simplifying here. The log to the base 8 of 64. I have to think of this. 8 to what power would give me 64? It'd be 2. Okay, because 8 squared, or 8 times 8, does give me 64. So log to the base 8 of 64 would be 2. And then minus, for this expression here, what rule can be used here? Well, it's to the 1/2 power, so that means I must use the power rule by bringing the 1/2 in front of log to the base 8 of the quantity x plus 1. Okay. Are there any questions about problems 1, 2, 3, or 4?
On number 2, for ln of 8, we don't simplify.
No, no. Any other questions? Okay, problem number 5. Here we're going to use the properties of logarithms to condense the logarithmic expression 5 ln of the quantity x minus 9 minus 2 ln of y. Here we're going to write the expression as a single logarithm whose coefficient is 1. Where possible, evaluate the logarithmic expression without using the calculator. So, in this case, here we've got 5 ln of the quantity x minus 9 minus 2 ln of y. Now, in this case, we need to have our coefficients for our natural logarithm to be a 1. So that means here we need to do this. Take those coefficients and make them exponents here. And the same holds here for the 2 ln y. Make that 2 an exponent for the y, because we're using the power rule, where we had to bring the exponent in front of the natural logarithm. Here we're going to do the reverse of that. So this 5 will be your exponent for the ln of 9. Ln of x minus 9. So it'll be ln of x minus 9, and that quantity will be to the 5th power. Minus this 2 becomes the exponent for y, so we'll have ln of y squared. Okay? What rule can I use to condense this expression? The quotient rule, because notice I have a difference of the individual logarithms. I can condense that as the natural logarithm of the quotient. So it'll be ln of, here the x minus 9, that quantity is to the 5th is in the numerator. Y squared will be in the denominator. Okay. Any question about problem number 5? Just condensing to a single logarithm.
So we don't work it out and get an answer, we just.
No, just do it like this. Okay. Any other questions? All right, number 6. Here we're going to use common logarithms or natural logarithms and a calculator to evaluate log to the base 14 of 87.5 to 4 decimal places. And in this case here, we're going to use the change of base property. Okay. Now, if you recall, the change of base property is this. You can write this as the log of the argument itself divided by the log of the subscript, or ln of the argument divided by ln of that subscript for this logarithm. So, if I use common logarithms, it would be this. The log of this argument, which is 87.5, divided by the log of our subscript, in this case, that would be 14. So in this case here, clear this junk out. All right, so here we got the log. We press the log key and then type in 87.5, and then you're going to close the parentheses around that 87.5. Because whatever that is going to be divided by the log of 14. Close parentheses and then hit enter. Now we want to give our answer to 4 decimal places, so what would this value be?
1.6944.
Right, 1.6944. Okay. All right, questions on problem number 6.
On this exam, what packets will we be testing on?
On
3 point.
for this exam,
Yeah.
it'll be 4.3, 4.4, 5.1, 5.2, and 5.4. Okay. Any other questions? Okay, number 7 and number 8. That's out of section 4.4. Dealing with the exponential and logarithmic equations. Actually, 6, 7, and 8 deal with, 7, 8, 7 and 8. Deal with exponential equations out of section 4.4. And then number 7, we have the equation 3 to the 2x plus 1, and that's equal to 27. And in that problem, you are to express each side as the power of the same base, and then equating the exponents. Okay, so now, I do have a base of 3 on the left side. Now on the right side, I have 27. I need to write 27 as 3 to some power, which can be done, but what's 3 to what power would give me 27?
3.
Just the 3. So 27 would be 3 to the 3rd. And if you didn't know that, you could did this along the side. Divide 3 into 27, that would go 9 times. 3 goes into 9 3 times, and then 3 goes into itself 1 times. You see you'll have 3 factors of 3. So it'll be 3 to the 3rd for your 27. Now you have your bases being the same, and if the bases are the same, I can set that exponent to be equal to that exponent. Meaning I can set 2x plus 1 to be equal to 3. And now solve for x. Well, if I subtract 1, that means 2x is equal to 2. And then if 2x equals 2, x has to be equal to what? 1. So x equals 1 is the solution to that exponential equation. Okay. So with this one, we had to express each side as powers of the same base to solve this exponential equation. Any questions on number 7? All right, problem number 8. Here we're going to solve the exponential equation 3e to the 5x is equal to 1977. Express the solution set in terms of natural logarithms and then use a calculator to obtain a decimal approximation correct to 2 decimal places for the solution. So here we got 3e to the 5x, and that's equal to 1977. Well, first of all, we need to get the exponential expression by itself, that e to the 5x. And to do that, we're multiplying it by 3, so we need to divide both sides of the equation by 3. So as you can see here, I'm going to have e to the 5x, and that's equal to 1977 divided by 3 will be how much? 659. Okay. So e to the 5x is equal to 659. And then, since e and the natural logarithm, or ln, are inverses of each other, we're going to take the natural logarithm on both sides of this equation. Because I know e and ln are inverses of each other. So that means here on the left side, if I take ln of e to the 5x, what would that be? Just 5x. So 5x will be equal to ln of 659. And then to get x by itself, we divide by 5. So that means x is equal to ln of 659 over 5. And of course, I think in the homework, when you were doing problems out of section 4.4, you had to provide the exact value. So ln of 659 divided by 5, which is equal to x, that's your exact value. And then for the approximate value, you have to use your calculator to do that. And this is going to be to 2 decimal places. So in this case here, if I press the ln key, and then type in 659, and you want to make sure you close your parentheses, because you only want the natural logarithm of 659. And whatever that value is will be divided by 5. And what would this be to 2 decimal places? 1.30. Or 1.30. So that would be your approximate value for x for this exponential equation. Right.
We don't have to do 4 decimal places on this one?
No. Okay, just follow the directions where it says. It says to 2 decimal places in this case. Any other questions? Okay. Problem number 9 and number 10 are logarithmic equations, also out of section 4.4. Now these are the ones, I will tell you right now, these are the ones you have to check your proposed solutions. Because you want to reject any value of x that is not in the domain of the original logarithmic expression. Okay? So in problem number 9, here we got the log to the base 2 of the quantity x plus 2 minus log to the base 2 of 7, and that's equal to 3. Now, with each side of this logarithmic equation, you want to condense as a single logarithm. So on the left side, what rule do I need to use to condense that expression? It's either product quotient or the power rule, quotient rule. Here I got the difference of the individual logarithms. I need to condense that as log to the base 2 of the x plus 2 will be in the numerator divided by the 7. That will be in your denominator. And then that's going to be equal to 3. And then the next step would be to write this in its equivalent exponential form. We need to convert this logarithmic equation into its equivalent exponential form. Meaning the subscript for your log is your 2. This 3 represents the exponent for your base. That's going to be equal to this argument right here. So that means I'm going to have 2 raised to the 3rd power, and that's equal to that x plus 2 over 7. And now let's simplify this. 2 to the 3rd power would be 8, and that's equal to x plus 2 divided by 7. And you know what I'm going to do here? Put the 8 as 8 over 1. And that'll be equal to x plus 2 over 7. And then I'm going to do some cross multiplication here. I'll do 8 times 7. And that'll be equal to 1 times x plus 2. So here 8 times 7 would be 56. And then 1 times x plus 2 ends up being x plus 2. So I get 56 is equal to x plus 2. And then to get x by itself, I'm adding 2, so I need to subtract 2. So x will be equal to what? 54. And I cannot end it right here because that is my proposed solution. Here I need to check the proposed solution to see if it does satisfy the original equation. So here's how we do the check. You start with the original equation. Replace the x with that 54. So here we got log to the base 2 of x, which is 54, plus 2, minus log to the base 2 of 7 is equal to 3. Now 54 plus 2 would be 56, so log to the base 2 of 56 minus log to the base 2 of 7 is equal to 3. And of course the difference of the individual logarithms is the log of the quotient, so this will be log to the base 2 of 56 divided by 7 is equal to 3. (56) divided by 7 would give you 8, so log to the base 2 of 8 is equal to 3. And then you can convert this to its equivalent exponential form, so it'll be 2 to the 3rd is equal to 8, and 2 cubed is 8. So that means that x equals 54 is your solution to that logarithmic equation. Okay, so on your exam, I would not only expect for you to show your work when you solve the logarithmic equation, I also expect that you provide the check to show that this is the actual solution to that logarithmic equation. All right, questions on problem number 9. Okay. Now, while problem number 9 has the logarithm on one side, number 10 has the logarithm on both sides of this equation. Here we got log of the quantity 5x plus 1 is equal to log of the quantity 2x plus 3 plus log of 2. In this case, we have the logarithm on both sides of this equation. But first, each side we need to condense as a single logarithm. So in this case here, the left side is already a single logarithm. The right side, I got log of 2x plus 3 plus log of 2. What rule can be applied here to condense as a single logarithm? The product rule. Because that's the sum of the individual logarithms, I can write that as a log of the product. So this will be the log of, and you know what I'm going to do? I'm going to put this 2 in front of 2x plus 3. So here I have a single logarithm on each side of the equation. Now here we have to use that one-to-one property for logarithms. And that one-to-one property states that if you have log to the base b of m equaling to log to the base b of n, then I can set those two arguments m equaling to n. That's what we call the one-to-one property. So that means these logs are the same, but you don't see the subscript. But what's it understood to be there? 10. Because this is like log to the base 10 here and log to the base 10 here. Since these logs to the subscript of the base 10 are the same, I can set this to be equal to that. I can set 5x plus 1 to be equal to 2 times the quantity 2x plus 3.
How did you put 10 as the base for the
Because, well, if you don't see the subscript for your logarithm, it's understood to be base 10. Okay. We call that a common logarithm because it has the understood base 10. Any other questions? Okay, so now let's go ahead and solve this equation. If I distribute the 2 over the 2x plus 3, what would I get? Not 2x. 4x plus 6. And now I need to get all the variables on one side of this equation and the numerical terms on the other side. So I need to move the 4x over to where the 5x is by subtracting 4x. So 5x minus 4x will leave me this x plus 1 equal to 6. And if x plus 1 equals 6, what must x have to be equal to? 5. Now that's my proposed solution. However, I need to check that proposed solution to see if it does satisfy the original equation. Okay, so using the original equation, I'll substitute every x in that equation with 5. So it'd be the log of 5 times 5 plus 1. And that's equal to the log of 2 times x, which is 5, plus 3, plus log of 2. All right. Now, if I do 5 times 5, that's 25. 25 plus 1 would give me 26. So it'd be log of 26 on this side, equaling to the log of 2 times 5, that's 10. 10 plus 3 is 13. And then plus log of 2. Now on the right side, if I have the sum of the individual logarithms, I can condense that as the log of the product. So it'd be log of 13 times 2. And what's 13 times 2? 26. So I have log of 26 equals to the log of 26. And I can end that check right here because the left side equals the right side. So that means x equals 5 is the solution to that logarithmic equation. Okay. Yes. Right here? We can't, because it says the sum of the individual logarithms. The rule is we have to condense it using the product rule. Any other questions? Okay, number 11 is a compound interest problem. It asks, how long will it take for an investment of $2,500 to grow to $5,000 if the annual interest rate is 7% and the interest is compounded continuously? Here you go, round the answer to one decimal place. All right, so let's go ahead and identify what we have in that problem. We have a $2,500 investment. That is what P will be equal to. And we want it to grow to an amount, which is A, of $5,000. The annual interest rate is given as 7%. Now, what's 7% as a decimal? 0.07. And we are told that the interest is compounded continuously. So that means the formula that we have to use for this situation, as far as compound interest is concerned, would be this. A is equal to P times e to the RT. Okay. So if you recall, for continuous compounding, we use this formula. It has the natural base e in it. And then we substitute into this compound interest equation. Your A is 5,000, so it'd be 5,000, equaling to P, that's 2,500, times E to the R, that's going to be 0.07. T is what we're trying to find, because it says how long will it take. So we're looking for the time, T. So this is our exponential equation for this situation. And now to get e to the 0.07t by itself, we need to first divide both sides by 2,500. So here we'll have the e to the 0.07t by itself. 5,000 divided by 2,500 will give us 2. So we have 2 is equal to e to the 0.07t. Now, since e and the natural logarithm are inverses of each other, we have to take the natural log on both sides. And then ln of e to our exponent is that exponent. So ln of e to the 0.07t will be 0.07t, and that's equal to ln of 2. And to solve for t, we divide both sides by 0.07. So we'll have t by itself, and that's going to be equal to, okay, this will represent the exact value. But here we want this to 2 decimal places, so we'll press the ln key, then type in 2, close parentheses, because we only want the ln of 2. divided by 0.07, and then press enter. Now the one decimal place, what would that be? 9.9 years. So it would take approximately 9.9 years for a $2,500 investment to grow to $5,000 at 7% compounded continuously. All right, questions on number 11. All right, number 12. It's from section 5.1, and that's systems of linear equations in two variables. And it does say solve the following system of equations using any method of your choice, and that's either substitution or addition. So you do have a choice there. And in this case, we got 3x minus 2y is equal to negative 5. And the other equation is 4x plus y is equal to 8. Now in this case here, which method would you like to use, substitution or the addition method? All right, we'll use the addition method. Okay, so that means here, which variable would you want to eliminate, the x or the y? The y. And that's because I know I have a minus sign here and a plus sign here. And I know I got 2y, so if I want this plus y to be plus 2y, I need to multiply that equation by what? By 2. So I'm going to take this equation, multiply it by 2. So the first equation, I'll just go ahead and bring that over. But for the second equation, if I do 2 times 4x, I'm going to get 8x. And then 2 times y will be a plus 2y equals 2 times 8, 16. Now we can add these two equations together. 3x plus 8x will give us 11x. That minus 2y and that plus 2y, they're gone. They add to 0. And that's equal to negative 5 plus 16. It's 11. So I have 11x equals 11. So to get x by itself, I need to divide both sides by 11. That means x is equal to 1. So I know what x is. I need to know what y is. Now I could use either the first equation or the second equation. Which equation would you want to use, the first or the second?
Second.
Let's use the second, because you just got a 1y here. So here I'm going to say using this equation, 4x plus y is equal to 8. We substitute the x with 1, so it'll be 4 times 1 plus y is equal to 8. 4 times 1, that's 4, so it'll be 4 plus y is equal to 8. Subtract 4 on both sides, you'll get y is equal to what? 4. So that means that the solution for this system of equations in two variables would be the ordered pair 1, 4. And I would expect that you would give that answer as a ordered pair. Because when you're solving a system of equations, you're looking for the ordered pair that will satisfy that system. Any questions on number 12? All right, now number 13 is a system of equations in three variables, and this is out of section 5.2. Here we got x minus y plus 3z is equal to 8. 3x plus y minus 2z is equal to negative 2. 2x plus 4y plus z is equal to 0. And in this case, we're going to solve this system of equations in 3 variables. And this is out of section 5.2, where you had to pick a pair of equations, eliminate a variable to get one equation in 2 variables, and then pick another pair of equations and eliminate that same variable. That way you'll have a system of equations in 2 variables. Okay, so that first equation will be equation 1. The second one will be equation 2. The third one will be equation 3. Okay, which 2 equations would you like to work with? 1 and 2. Because notice on the y, I have a minus y and a plus y. So let's do this. Equation 1 is going to be that x minus y plus 3z is equal to 8. Equation 2 is 3x plus y minus 2z is equal to negative 2. I can go ahead and eliminate the y. So now, x plus 3x will be 4x, minus y and the plus y are gone. And then 3x minus 2z will be plus z. And then 8 plus negative 2, 6. So I got 4x plus z is equal to 6. This I will label as equation 4. Now I need to pick another pair of equations and eliminate that same variable. So here, the next pair of equations I pick, I have to eliminate the y. So which other two equations would you want to work with? Let's try, which one? 2 and 3. Okay. I would say one, well, let's see how this is going to work out. Now we have to eliminate the y. Notice I got 4y in that third equation. The second equation, if I want that to be minus 4y because I need opposite signs, I need to multiply that first equation, that second equation by what number? Negative 4. So I'm going to multiply the second equation by negative 4. And when I do that, that negative 4 times the 3x will be negative 12x. Negative 4 times the plus y will be minus 4y. And then the negative 4 times the minus 2z will be plus 8z. And it's equal to negative 4 times negative 2, 8. Equation 3, I will bring that over. And then we'll add those two equations together. Negative 12x plus 2x will be negative 10x. And then minus 4y and that plus 4y add to 0. That's gone. 8z plus 1z will be plus 9z equals 8 plus 0. 8. So I have negative 10x plus 9z is equal to 8. This is equation 5. Okay, so now, equations 4 and equation 5 are in 2 variables, x and z. So here's equation 4, that's 4x plus z is equal to 6. Equation 5 is negative 10x plus 9z is equal to 8. So from those two equations, which variable would you like to eliminate, the x or the z? Well, let's eliminate the z. Because all I have to do there is just multiply one of those equations by a non-zero number. And notice I have 9z. If I want this z to be minus 9z, I need to multiply that equation 4 by what? negative 9. Because I work with the x's, that means I need to find a least common multiple for 4 and 10. So here's what we'll have. Negative 9 times 4x would be negative 36x. Negative 9 times a z would be negative 9z, and it's equal to negative 9 times 6, negative 54. And I'll bring over that equation 5, that's negative 10x plus 9z is equal to 8. Now, negative 36x and a negative 10x, negative 46x. And then the minus 9z and the plus 9z, they add to 0. And then that's equal to, what's negative 54 plus 8? Negative 46. So here we got negative 46x is equal to negative 46. And to solve for x, we just divide both sides by negative 46. That means x is equal to 1. So I know what x is. That's going to be equal to 1. Now, I need to use either equation 4 or equation 5 to find out what z is. Okay, let's use equation 4. And equation 4 was that 4x plus z is equal to 6. And x is equal to 1, so we just substitute that x with 1, so it'll be 4 times 1 plus z is equal to 6. 4 times 1 would be 4, so 4 plus z is equal to 6. And if that's the case, what must z have to be equal to? 2. So z is equal to 2. Now I have to go back to either equation 1, 2, or 3, since it's they're in 3 variables, and substitute the x with 1 and the z with 2 to come up with what y is. Okay, yeah. Tell you what. Let's use 2. Because notice on equation 2, I have a 1 coefficient for the y. I mean, you could use the other 2, doesn't matter. X is 1, so it'll be 3 times 1 plus y is what we're trying to find, minus 2 times z, which is 2, and that's equal to negative 2. 3 times 1 would give me 3, plus y minus 2 times 2, which is 4, equals negative 2. Bring this y down. What's 3 minus 4? Negative 1, so you have y minus 1. That's equal to negative 2. And what must y have to be equal to? Negative 1. Okay, everyone see that. So the solution for this system of linear equations in 3 variables, we start with the x, which is 1, the y, that's negative 1, then z, 2. And you have to write this as an ordered triple as your answer. 1, negative 1, 2. Are there any questions about example 13? All right, number 14. Well, 14 and 15 out of section 5.4. Number 14 deals with the substitution method. And these are systems of nonlinear equations here. So here we got 2x plus y is equal to negative 5. And the other equation is y is equal to x squared plus 6x plus 7. this is just me, I'll just write these equations side by side. And notice that second equation, we have y equal to something, which is, of course, x squared plus 6x plus 7. So here's what I'm going to do. I'm going to take this expression, x squared plus 6x plus 7, which is what y is equal to, and substitute it for this y in that first equation. That way, I will have an equation in a single variable. So in this case here, let's say we bring down the 2x plus the y will be replaced with that x squared plus 6x plus 7. And then that's equal to negative 5. Now I'm going to write this in descending power. So here, I'll pull the x squared in front, add 2x and 6x. That's going to give me 8x plus 7 is equal to negative 5. Now here I have a quadratic equation. And to solve a quadratic equation, you want to make sure you have a 0 on one side of this equation. That means I need to move the minus 5 over to where x squared plus 8 plus 7 is by adding 5 to both sides. So here I have x squared plus 8x plus 12 is equal to 0. And let's see if we can factor the x squared plus 8x plus 12 into two binomials here. I have x squared, that's going to be x and x. Now what factors of 12 would give me 8x as a middle term? 6 and 2. And they both have to be plus because the middle term and the last term are have plus signs. So I have x plus 6 times x plus 2 is equal to 0. And then we set each binomial factor equal to 0. So that means x plus 6 is equal to 0 and x plus 2 is equal to 0. And then we solve each equation for x. So for the x plus 6 equals 0, x must be equal to what? Negative 6. And for the x plus 2 equals 0, x has to be equal to negative 2. So I have two values for x. X is equal to negative 6 and x is equal to negative 2. For each of those x values, I need to find out what y is. Well, I have the y equal x squared plus 6x plus 7 already. So let's use that. We'll start with the x equal negative 6. And the equation for y, that's equal to x squared plus 6x plus 7. And then we just substitute every x in that equation with negative 6. And simplify. Square negative 6, you're going to get just 36. Negative times negative is a positive. 6 times a negative 6 will be now negative 36 plus 7. And of course that 36 minus 36, that gives you 0. 0 plus 7 is 7. So when x is negative 6, y is 7. That's one ordered pair for this system, nonlinear system of equations. Now, let's try to find out what y is when x is equal to negative 2. Using that same equation, y is equal to x squared plus 6x plus 7. We replace the x with negative 2. If you square that negative 2, you're going to get 4. 6 times the negative 2 will be negative 12 and then plus 7. What's 4 minus 12 plus 7? Negative 1. So when x is negative 2, your y value will be negative 1. And you do have to write this as ordered pairs. So negative 6, 7, and negative 2, negative 1 are the ordered pairs that satisfy this nonlinear system of equations. Are there any questions about number 14? And finally, number 15 is solving the system by the addition method. So in this case here, we got x squared minus 4y squared equal negative 7. And then 3x squared plus y squared equals 31. In this case, which variable would you like to eliminate, the x squared or the y squared? Y squared. Let's eliminate that. In the first equation, I do have the minus 4y squared. If I want this y squared to be 4y squared, I need to multiply that equation by what? By 4. So that second equation will be multiplied by 4. This is what I'll have. The first equation, I'll rewrite that. So if I do 4 times 3x squared, I'm going to get 12x squared. And then 4 times the y squared will be a plus 4y squared equals 4 times 31, 124. All right, now we're going to add the two equations together. A 1x squared and a 12x squared would be 13x squared. The minus 4y squared and the plus y squared, they're gone. They add to 0, and that's equal to negative 7 plus 24, 117. So I have 13x squared is equal to 117. Now to get x squared by itself, I need to divide both sides by 13. So that means x squared is equal to, what's 117 divided by 13? 9. So x squared is equal to 9. And what's the opposite of squaring something? Square root. And if I take the square root on both sides, I must include plus or minus. So that means x is equal to plus or minus the square root of 9 is 3. So that means I have two values of x. X is equal to 3, and x is equal to negative 3. Now the next step would be to find out what y is for each of these x values. Okay. Let's see here. If I use equation number 2, and I'm talking about the original equation that I started off with, and I'll start off with x equals 3. That second equation I'm going to be using is x squared plus y squared is equal to 31. And replace the x with 3, so it'll be 3 times 3 squared plus y squared is equal to 31. 3 squared is 9. 9 times that 3 is 27. Plus y squared is equal to 31. Now what do I need to do to get y squared by itself? Subtract 27. So that means that y squared is equal to 4. Then if I take the square root on both sides and include the plus or minus symbol, that means y is equal to plus or minus square root of 4 is 2. So for x equals 3, I have two values for y, positive 2 and negative 2. Now for x equal negative 3, it's going to end up being the same thing for y because of the fact when I replace the x with negative 3, And then you're squaring it. It's going to end up being positive 9 times that 3 is 27. Plus y squared is equal to 31. So if I go through all of this, it's going to be the same thing. So I'll just skip some steps here and just say y squared is equal to 4. And then y is equal to plus or minus 2. Because I know I have to take the square root on both sides and include the plus or minus symbol. So I also have two y values when x is equal to negative 3. Positive 2 here and negative 2 here. So these are all of the 4 solutions that satisfy this system of nonlinear equations. 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 2. Are there any questions about problem number 15? Or does anybody have any questions about what will be on exam number 4 on Tuesday?